All right, everybody, get ready, because we are diving into a theory today that is causing quite a stir. It's called the grand design theory of gravitation.
And it's a big one. This theory is really shaking things up in the physics world.
Yeah, we've got excerpts from a brand new book about it. God, Gravity, and the Grand Design. Einstein's mind-blowing mistake.
By Tom James.
Right, Tom James. And there's even a New York Times article creating a buzz and a radio interview with James himself.
And the really interesting part is that this theory isn't just some small idea, it's actually a potential theory of everything.
A theory of everything.
Yeah, like a complete theory of the universe.
Wow. So James is suggesting in his book that Einstein actually made a big mistake about gravity.
A mind-blowing mistake. A mind-blowing mistake about gravity, yeah.
Okay, so let's break it down. What's the main idea here? Einstein was wrong about gravity. Like, how?
Well, James points to Einstein's own work where he connects acceleration and gravity.
Okay.
This connection that Einstein himself made implies that there must be a force involved in gravity, not just the bending of space-time, which is what Einstein said later.
It's like that thought experiment. Like, imagine someone standing on a rock accelerating through space.
Exactly. He'd feel that same force pushing him down, just like standing here on Earth.
Right.
So if acceleration needs a force, gravity must need a force too.
Because they feel the same, right?
Exactly. And get this, James argues that what we think of as non-motion is really just an illusion. Everything, he says, is in constant motion.
So everything is always moving.
Always. He uses the Earth as an example. We might think about it as being still, but it's spinning on its axis and also orbiting the sun.
Oh, right, yeah.
It's a perpetual motion machine.
Okay, well now here's where things get really interesting. James doesn't just talk about this in theory. He's actually created what he calls a blueprint for gravity. An actual diagram, like an engineering diagram.
It's like the blueprints for a complicated clock. You see all the gears, all the parts, how everything interacts.
And this blueprint isn't just about Earth. It's about how spherical objects form everywhere in the universe.
Imagine two incredibly strong forces pushing in on matter from opposite directions. It's like the universe is making a giant panini, squeezing planets and stars into those perfect spheres.
I like that analogy. And he even compares this to a magnifying glass.
It's like a magnifying glass concentrates sunlight into a single beam. These opposing forces amplify their power towards the center and extend outwards as gravity.
Okay, so we've got this potential new understanding of gravity, but then James takes it even further. He wants to tackle the Big Bang.
And his starting point is a bold one. What if, he asks, matter was already here when the Big Bang happened?
So it wasn't the beginning of everything.
Not necessarily. This solves a lot of problems with the traditional Big Bang theory. We no longer have to explain how the universe came from nothing or why it was so hot and dense. James suggests that instead of a singularity, there were two massive supernova-like explosions near the Big Bang.
Like two cosmic firecrackers.
Exactly, pushing all this pre-existing matter outward.
Okay, so we're talking about a potential new theory of gravity, right? And a new way to think about the Big Bang. And it gets even more interesting. James also wants to reconcile Einstein's theory of relativity and quantum mechanics. Can you believe that?
Two huge theories that are very hard to put together.
Right.
He's trying to bridge the gap between really big things and super tiny things in the universe.
And how is he going to do that?
James says the difference is all about mass and inertia.
Inertia.
That's the resistance to changes in motion.
Okay.
Big objects like planets, they have a lot of inertia. Their movements are predictable. But tiny particles, they're like ping pong balls in a tornado, subject to tons of unpredictable forces at their level.
So it's large-scale predictability versus small-scale chaos.
Exactly. And that difference is key to getting these two theories to work together, according to James.
Okay, but this is all pretty radical. I mean, what kind of evidence does James have for this grand design theory?
Well, that's where things get interesting. The main source right now is James himself and his book, which he says is based on 8,000 hours of research.
8,000? This guy is serious.
Oh, yeah. And in the radio interview, he talks about finding a mathematical link between electromagnetism and gravity. That's huge.
If he can actually do that, it would be revolutionary.
It would be. He's also connecting his theory to the idea of fine-tuning the fact that the universe's settings seem perfect for life to exist. like the strength of gravity, the speed of light, all of it.
Yeah, it does make you wonder, why are those numbers what they are?
Right. James argues that this fine-tuning isn't random, that it points to a deliberate design, like someone carefully crafted the universe for a specific purpose.
That's a pretty big claim.
It is, and it's definitely one that's going to generate a lot of discussion. It's definitely a lot to process, but that's what makes this so fascinating, you know? We're talking about potential scientific revolutions here.
Yeah, I mean, this could change how we see the entire universe.
Right. And it makes you think, what are the implications? What does it all mean if even one part of this is true?
Well, about that, let's talk about that perpetual motion thing for a sec. That feels like, I don't know, almost like science fiction.
Huh, yeah, it seems pretty out there, right? Goes against what we thought we knew about physics.
Yeah, but remember, James says that non-motion is an illusion.
Right, and if everything is always moving.
It's already perpetual motion.
Exactly, we just don't know how to tap into that yet to build machines that work with that universal motion instead of trying to create motion on their own.
Oh, I see what you mean. It's like we've been trying to reinvent the wheel when it's already right there in front of us.
Yeah. But we do have to remember that this idea depends on his theory of gravity being right.
Which is a big if. But okay, let's just say for a minute that James is right. No non-motion, perpetual motion is possible. We crack the code. What happens? What would that even look like?
The possibilities are huge. Imagine a world without energy where he's clean, limitless power.
No more oil wars. No more climate change from energy production.
It would revolutionize everything. Transportation, agriculture, manufacturing. We could solve some of the world's biggest problems. Poverty, hunger.
Wow, that would be incredible. But even if we don't get to that right away, just think about space travel.
Oh, right. If we could harness perpetual motion, sending spacecraft across the universe would be a whole lot easier. No more huge fuel tanks.
We could actually explore the stars. The ultimate road trip.
Exactly. And think about it, this new form of energy, it could lead to huge breakthroughs in everything. Technology, medicine, communication. The possibilities are really endless.
It's like opening up a door to a whole new stage of human progress.
I know, it's exciting to think about.
It is exciting. Okay, but while we're talking about changing how we see the universe, there's this other big idea in the book that we need to talk about. God.
Oh, right. Yeah, James doesn't shy away from that at all.
He actually says his theory provides new evidence for God.
It's definitely a bold claim, and I'm sure a lot of people will have a lot to say about it.
Yeah, and it'll be interesting to see how it plays out. But let's break it down. What's he actually saying?
Well, he's pointing to the complexity of his grand design, saying the universe follows specific rules, understandable rules, like a perfectly built machine.
Like someone actually sat down and designed all the pieces.
Exactly. Every gear, every spring, all the tiniest details designed to make sure the universe works exactly the way it does.
And he brings up that fine-tuning idea again. How the values for gravity, the speed of light, all of that is so precise.
Right. He's saying that kind of precision, it can't be an accident, that it points to intention, plan. Like if you found a watch on a beach, you know someone designed and built it. It didn't just randomly come together from grains of sand, you know?
Right. That makes sense. But I mean, we do have to point out this is where James is getting more speculative.
Yeah, this is where the hard science starts to blend with philosophy and personal interpretation.
It really makes you think about all the stuff we still don't know. Like we're just scratching the surface.
It's true, and even our most basic understanding of physics could be completely wrong.
Kind of cool though, right? I mean, that means there's still big discoveries waiting to be made.
Definitely. And who knows, maybe someone listening to us right now will be the one to make the next big breakthrough.
I love that. It's like that's why we do this show, you know, to get people thinking about these big ideas, maybe spark some curiosity.
Exactly. It's all about starting the conversation, right? We're not saying we have all the answers or anything.
Not at all. We're just diving into these fascinating ideas, but we want people to go out there and keep exploring, keep learning.
Absolutely. Read James's book, do your own research, come to your own conclusions. Don't just take our word for it, you know?
Definitely not. Learning should be active. It shouldn't just be passive. You got to question things, challenge your assumptions, maybe even come up with your own theories.
Exactly. Maybe you'll be the one to design the first perpetual motion machine. Or prove Einstein wrong about gravity? Who knows?
Wouldn't that be something? But okay, before we wrap up, I want to bring it back to something you said earlier about non-motion being an illusion.
Oh, right. That's a big one.
It is. So if that's true, that the universe is constantly changing, constantly moving, what does that mean for us? Like, are there things we can't even see or understand right now because of how we perceive the universe?
It's a really interesting question. If our fundamental understanding of reality is flawed, what else are we missing? What's out there that we haven't even begun to imagine?
It's like we're standing on the edge of something huge, something we don't fully understand yet. But it's out there, waiting for us to discover it.
Exactly. So keep asking those big questions, keep exploring, keep that curiosity alive. That's how we make progress. That's how we learn and grow.
Couldn't have said it better myself. So, until next time, keep diving deep, everybody. And as always, thanks for listening.